Welcome to Exploring Computing. Today's video is computer security, attack vectors, and techniques. So we're going to talk about a particular attack vector that can be used to compromise your computer security, specifically social engineering. And then after our discussion on social engineering, we're going to look at a variety of technical issues involved in various types of attacks on computing systems. Social engineering is one of the easiest ways to compromise somebody's computer security. It's also the one area where you as a non-programmer can make a huge difference in protecting your computer security. Basically, in social engineering, the attacker is going to ignore the technical aspects of the security system and instead go for the weakest link, which is the humans involved in the process. So, for example, in the old days, somebody would call up the tech support for a company and say, "Hey, I'm Bill Gates, CEO. I forgot my password. Can you go ahead and reset my password?" And while that may not have happened at Microsoft, this has definitely happened at other companies. At this point, of course, that whole process is much more automated. But nevertheless, these sorts of things continue to happen. So if somebody's trying to break into a particular account, they call tech support pretending to be you. They may not be able to get through the first time, but they slowly gather more and more information by talking to different tech support staff or customer support staff about that person. And over time, they're able to get enough information about this person whose account they're trying to break into in order to fake out the tech support person or customer support person into thinking they really are who they say they are. This is particularly problematic for famous people who already have a lot of information out about them. And you may remember that a while back there was a series of hacks where different actresses had their photographs stolen, and it's believed that this is the technique that was used. They would call tech support, pretending to be that particular actress. They were convincing enough that the tech support people were willing to help them out and reset the password or something like that. And then they were able to break into the account that way. Probably the best known example of a social engineering attack is phishing. Phishing is where you receive an email or text message purportedly from a company, and that attack attempts to get you to enter account information and password or otherwise send along secure data that the attacker should not have access to. So one thing to keep in mind, based on what you now know from this class, is that it is trivially easy to reproduce a web page. What do I need to do in order to get a web page to look exactly like the original web page? Well, I copy over the HTML file, I copy the CSS, I may copy the images. In some really brazen attacks, you don't even bother copying the images. You just use the real images on the real website, and you just have your own HTML and CSS. Trivially easy to perfectly, exactly replicate a web page so it looks exactly like the original. So what are you going to do to prevent these types of attacks? Well, don't ever click on a link on an email message. If you get a message that there's a problem with your account, don't click on the link. Instead, go to the main website for that company. I say the main website, meaning also don't just look at the URL provided in the email message and try and type it letter for letter. www-tech-support-, don't do that. Just go to the main website, type it into the web browser yourself, or alternatively, call the company directly using a telephone number. Get the telephone number from somewhere other than the email message. Like, let's say it's claiming to be your credit card. Flip the back of your actual physical credit card, look at the number there, call that number. Do not call any number provided in the email message. It's call the number on the back of your card and say, "Hey, I got this email message. I don't know if it's a fraud or this is a real deal. Can you tell me what's going on?" So, be very, very leery of clicking on anything in an email message. Remember, email is very insecure. The sender can be very easily faked. The reply to field can be manipulated. So the email message that you're replying to is not going to the original sender. It's going to somebody else. SMTP servers These are the servers used to send email messages as opposed to the ones that are used to receive and read our email messages. Were originally designed for open access. I think they are more and more requiring people to use accounts, but nevertheless, the original architecture was anybody could use any email relay to send their messages. So the whole system was just designed completely for insecurity. In addition, traditionally, the email messages themselves have not been encrypted. What has been changing is that many of the major email sites have switched to requiring HTTPS. And so as long as you are communicating with the server using HTTPS, any traffic to that website is using HTTPS. So if you, for example, were to go to www.gmail.com using HTTPS, people would not be able to see that traffic specifically. But just keep in mind, the whole email system, again, is very badly designed from a security standpoint. A lot of it is just completely insecure. And again, it is trivially easy to fake the sender on an email message. Okay, so I think one of the scariest types of attacks is a spear phishing attack. Whereas general phishing emails, I mean, we probably all get them. In fact, I know you get them because you're a Stanford student and Stanford gets attacked. So we get messages purported to be from Stanford security, telling us to log into a particular thing and reset our password. And hopefully they're pretty obvious, although, you know, I'm sure it could be pretty easy to accidentally click on the message and end up being John Podesta, who you'll recall, clicked on a message he thought was from Google and reset its password, and therefore all the Hillary Clinton campaign emails got released. Spear phishing, though, is much more difficult to prevent. What happens in spear phishing attack is the attacker wants to attack a very specific person. The attacker is going to study their target. They're going to learn about the target's jobs, what sorts of things that the target carries out on a regular basis, what sort of email messages the target might expect to receive, who the target's coworkers are, what sort of positions they carry, what sort of messages they might be expected to send the target. And then what they do is they create a carefully crafted email of the type that the target would typically receive. That email may appear to be coming from a coworker. And in fact, they can add in extra information into the email message, depending on how thoroughly they want to research this, you know, like, hey, and it was great seeing you at the party last Friday where we saw Sarah and John. And so it looks exactly like it's coming from your coworker. And so you go ahead and click on the link, or you open the attachment or whatever. And so again, I don't know a great way to prevent this sort of attack other than just being super, super paranoid. I will say when I receive messages from students that have attachments, I'm far more likely to try and open those attachments on my iPad than I am on a PC, because the iPad is more of a walled garden where it's difficult for attackers to break out of the email box and do attacks on my computer. So, you know, obviously in a lot of cases, I do have to open attachments on messages from students, and I don't know who the students are. So, you know, this is an area where you're super vulnerable. Again, I don't know any particularly great ways to prevent it, but I do think my opening email messages on the iPad is better than opening them on my PC. The PC is just easier to attack, and it's more likely that anyone not listening to this video would send an attack on the assumption that I would be opening on a PC. All right. It's also possible to mix social engineering with more technical attacks. So, you know, I mentioned earlier that last lecture when we talked about how Stuxnet was designed to attack the Iranian nuclear refinement facilities. Probably the Iranian nuclear refinement facilities had an air gap, which is to say that they were not directly attached to the internet. So in order to get on the internal network not attached to the internet, whoever attacked those computers must have had a way to get into that non-attached network. And so one way of doing this is with a USB drive. So they could have sent in an actual physical agent and stuck a USB drive into one of these computers. But it turns out that using social engineering, you can actually get people to stick things into their own USB drives without you having to actually be there. And so the Department of Homeland Security did a test where they went outside of government facilities and they dropped a bunch of USB drives. And what was actually on the USB drive was a program that would contact the Department of Homeland Security and say, hey, such and such a USB drive was plugged in. Here's the computer it was plugged into, and then Homeland Security would follow up and say, hey, we dropped this dummy attacker USB drive out in the parking lot. Somebody plugged it into such and such a computer. But that drive could also be not from the Department of Homeland Security, not a part of a test exercise, but actually contained some sort of a malicious payload. What they found was that 60% of the drives they dumped into parking lots were picked up and plugged into computers. But if they actually added a logo to the USB drive, 90% of them were plugged in. So like, let's say you're out in front of the U.S. Geological Survey office, you put a USGS logo on the drive, you drop it in the parking lot, that greatly increases the chance somebody's going to take it and plug it into one of the computers. To provide another example, at the recent U.S. North Korean conference, some company handed out a bunch of USB-powered fans, and people were like, it's really hot this outside. This is really nice. I have this fan. I want to be able to use this mini fan. Oh, look, it's got a USB connector that's providing power. All I need to do is plug this into my computer USB port to provide power, and then I will have a nice fan. And the security experts were like, this is a really bad idea. They did study them, and as far as they were able to discern, none of them had payloads. But you could easily imagine somebody being like, oh, this is a cute gimmick. Oh, I understand. I need to plug into my computer to provide power. That's pretty normal. Great, let's go ahead and do this. And in fact, it includes some sort of a payload that attacks your computer. So don't plug anything into any of your computer ports unless it's coming from a trustworthy source. Okay, so again, I really do want to emphasize social engineering because this is the one attack area that you all can make the biggest difference. And so, pay attention. Again, with the phishing attacks, never click on a link in an email message. Assume that it's leading you somewhere nefarious, even if it looks legit. So there's various techniques that people can do to make addresses look legitimate, even though they're not. So, maybe the normal dot is replaced by a dash. So, just be super careful. Don't click on those links. Instead, again, just open up a web browser and the name of the company. What their regular web address is. Go to that regular web address and log in that way, or again, call them up by phone. Okay, now we're going to take a look at more technical ways attacks can occur. The first one I want to talk about is something called SQL injection. And so I really like this cartoon from XKCD. Thank you to XKCD for allowing use of their cartoons by nonprofits. There's a link to the cartoon down below. I think this really illustrates SQL injection really well. So here's a little cartoon. You can see somebody's calling this mother and they say, hi, this is your son's school. We're having some computer trouble. And she says, oh dear, did he break something? And they say, in a way, did you really name your son Robert, quote, parentheses, semicolon, drop table students, semicolon? Oh yes, little Bobby tables, we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you learn to sanitize your database inputs. So what's going on here? This is an injection attack. In an injection attack, the attacker enters code in a place where the system only expects text. So the idea here is, here's the name of the student, Robert, quote, paren, And so that quote after the name Robert terminates the string from the standpoint of whoever is taking the string from this text field and sticking it into part of a SQL command. And so they're basically just taking text, inserting it into a pre-created SQL command, and slapping this text string onto the end of some text that they've already provided. And so the effect here is that end quote after Robert terminates the string, and then the rest of this stuff gets directly inserted in as an actual command, which will actually be executed by the computer, in this case using the SQL database. And the result is it destroys the students table. So the solution to this is you need to do what's called sanitize your inputs. And so the idea here is you need to set up your code in such a way that anything the user provides is strictly treated as text and cannot be accidentally interpreted as a command. So really a SQL injection attack, or any injection attack, is the result of the programmer being sloppy and writing code that's quick and easy for them to write without going through the extra step of saying, I'm going to take this input that the user's entered, and I'm not just going to attach it to the end of some pre-existing command. I'm actually going to convert the entire thing explicitly to something that cannot be treated as a command, and that's what I'm going to use as a string. We've talked earlier in the quarter about how when you have the name of an HTML file, I recommend you just use letters, numbers, and the dash. And that if you use additional characters, like say the space character, they actually get encoded in the special URL encoding. So a space, for example, you've probably seen this occasionally on actual websites. A space actually gets converted to a %20, which ends up being the ASCII code for a space. And so that's an example of encoding. So what's going on there is the coding process is saying, I don't want to treat this as a space, which has actual syntactic meaning in places where I might use the string. So I'm going to convert it to the sequence of characters %20, which cannot be misinterpreted as part of the syntax characters for whatever purpose I might be using this particular string for. So you need to do the same thing, or the programmer needs to do the same thing on their side. They need to take that, whatever the user's entered, and use some sort of an encoding that is going to remove any of the characters that might be misinterpreted in the particular language, and in our little example here, in the SQL language, as potential commands. Okay, cross-site scripting. Contrary to the name of this particular attack technique, this is another type of injection attack. In this case, though, we're actually going to inject script into somebody else's web page. And so an example of this is, suppose we've got a website that displays usernames or maybe user comments, like maybe it's a bulletin board or it's a newspaper that's running its own comment section. And what they do is they allow people to enter, say, for example, their name. They allow them to enter a comment. They take that information, stuff it in a database, and then when somebody else comes to visit that website, they take that name and comment and just stick it back out on the web page. So what you're going to do in this particular type of attack is, instead of entering a username, or maybe instead of entering that comment, you're actually going to stick in JavaScript code, including a script tag. And if the server is not sanitizing its inputs, it's just taking the information that the user's entered into the text field or the text area, it's going to stick that script tag back out, and it will send your JavaScript that you've injected out to anybody's web page that visits that website. So that's a cross-site scripting attack. And the protection against cross-site scripting is to sanitize your inputs. Make sure that regardless of what the user enters, it is not treated as actual HTML, that it is instead treated just as text. So, maybe you can get rid of that less than sign, or you can look specifically for tags and just say tags are not allowed. Get rid of any less than signs, greater than signs, or something like that. Okay, clickjacking. Clickjacking attacks causes the user to unintentionally click on something. This can be used for a bunch of different purposes. So, for example, it could be used to increase ad counts, or it could be used to cause the user to inadvertently purchase something through Amazon's one-click purchase link. Okay, let's walk you through how a clickjack attack works. This requires knowledge of a bunch of different HTML tags and CSS properties. So the first one is an iframe. An iframe tag allows the user or the creator of a web page to place a different HTML page within the main HTML page. So in this particular case, I'm using the iframe tag, and I'm sure we've got cat fans out there who are unhappy with all my dog examples. So what we're going to do here is we're going to put a cat example in the middle of my dog example here. And so you can see that cat section down in the bottom right-hand corner. That is actually a different HTML file, and it's been inserted by using this iframe. So as you can see, the iframe refers to source cats.html. And so we're actually going to load up the cats.html file. So the cats file has its own section, which is being displayed in the web browser within my dogs file here. Step 2, I need to know about something called cascading style sheets positioning. Cascading style sheets positioning allows me to move elements around the web page and place them wherever I want. So in this particular case, I have moved the cat's iframe from the lower right, and I'm actually placing it in the top left-hand corner. And when you place something absolutely, it actually overlays anything that's underneath it. So the cat's iframe is now on top of the information about dogs. And now what I'm going to do is I'm going to change the opacity of that iframe. I've reduced the opacity to 25% so we can actually see it. But in a real clickjacking attack, which you could make it just completely invisible. So what we've got is we've got a part of our web page which actually is a different website or a different web page. In this particular case, it's a different web page. Cats.html and dogs.html are on the same website, but this could just as easily be a different website, say, for example, Amazon, and it would be completely invisible. So that's there on the web page, but the user can't actually see it. And then the last thing we do is we have something on our web page that we think the user will click on. So maybe there's a link there, or there's a button which claims it does something. And so the user clicks on a particular location on our web page, but what they're actually clicking on is they're clicking on the invisible iframe, which is actually a different website. Say, for example, an invisible copy of Amazon positions exactly so that the one-click purchase button is in the exact location where we're making the user think if they click on that location, something different will happen. So they go to our website, they click on what they think is one thing, but they're actually clicking on an invisible iframe showing something we're trying to get them to purchase with the one-click button directly on the location where they're clicking. Okay, so how do we prevent a clickjacking attack? So this is really up to the websites who don't want this sort of attack to happen to them or their customers. And so what you can do if you're Amazon is you can make sure that your web page will not be displayed within an iframe. There's several different techniques to do this. You can include information in the HTTP header. You'll recall that includes things like, hey, this is how long this web page is good for. This is when it expires, or this is a particular encoding we've got. You can also send information in those headings that say, web browser, don't place me inside of an iframe. You can also use JavaScript to force your web page to the top of the frame hierarchy. So there's a bunch of different ways to prevent clickjacking, but it does depend upon the creator of a website realizing that clickjacking is a thing and making sure that their website can't be used in conjunction with a clickjacking attack. One thing that some programs depend upon, particularly web browsers depend upon, is something called Sandbox security. And so the idea behind Sandbox security is client-side programmers running in a web browser can do a certain number of things to interact with the computer. So, for example, they can control what's being displayed in the web browser window. And so things that the website can do, those are considered within the sandbox. And things that website can't do are considered outside of the sandbox. So, for example, accessing files on the user's computer, that is outside the sandbox. So a web browser will not allow a website to directly access the file system. Accessing the camera and microphone are generally outside of the sandbox, although I think increasingly you may see that that's sort of included in the sandbox, but needs special permissions. But the basic idea here is the program, in this case, the web browser, is saying, hey, in order to allow people to create cool and interesting websites, we want them to have access to a whole bunch of different capabilities. That stuff is going to be in the sandbox, but then we need a clear delineating line on what is outside the sandbox and what they can access. So, in case you're wondering, probably already figured this out, but this comes from the idea of you can put your kid in the sandbox and the kid can play around with their toys. And as long as they stay in that sandbox, they're in a safe environment. But we don't want them to, get out of the sandbox and, maybe the pool's nearby. We don't want them to go to the pool. We don't want them to accidentally get in with the dogs at the dog park. So that's the idea behind sandbox security. Now, the one thing to be aware of is there are a variety of different ways to get outside of the sandbox. And in particular, plugins or extensions often have access outside of the sandbox. So you should be really cautious installing plugins or extensions. I think the web browsers have gotten a bit better on specifically telling you what that web browser plugin wants access to. But just be aware, if you stick in a plugin, that plugin may have access to absolutely everything. So if you go to a website and the website is like, hey, you need to download this plugin in order to view this web page properly, unless you're sure you trust that website and you trust whoever made that plugin, say no. It's not worth it to randomly see something in 3 dimensions and risk compromising your whole web browser security, including all your banking information. So, say no unless there's a good reason to say yes, and unless you really trust this person. Okay, on a somewhat related note, there's something called drive-by download. And drive-by download tries to get you to install malicious software. So our example of the web browser plugin, that could be an example of drive-by download. How do we get the user to install software? Well, one thing we might do is we might depend upon the gullibility of the user. So they visit our website and, we claim there's a plugin that they need to download, or, we start up a download message being like, hey, we think you have a virus, click here and we'll clean it up for you. Alternatively, web browsers will sometimes have security vulnerabilities that allow the website to download something on the computer directly. So a computer or a web browser vulnerability could be identified where if you visit the website, it forces the download or the installation of something. Okay, man-in-the-middle attacks. In the man-in-the-middle attack, what we do is we insert a malicious computer between the victim's computer and the computer they are trying to communicate with. And the idea behind a man-in-the-middle attack is we want to make it invisible to the victim that they actually are being attacked. So suppose I'm trying to communicate with my bank, and there's a malicious computer between me and my bank. And when I enter my name and password, I think I'm communicating with my bank. But what's actually happening is I'm passing my name and password to the malicious computer, and the malicious computer is taking that information and passing it onward to my bank. The bank sends the information back to the malicious computer thinking it's me, and the malicious computer passes the information on to me. And as far as I'm concerned, it looks like I'm actually properly communicating with my bank, but in fact, there's a hacker in between us. This can, among other things, be used to get around two-factor authentication, where I try and log into my bank, but my account is set up with two-factor authentication, which is a really good thing. We'll talk more about it next lecture, where the bank sends me maybe a text message with a number on it. It says, okay, Patrick, I see you're trying to log in. You seem to be logging in from this random location I don't know about. So I texted you a message with an identification number. And so what can happen is I enter my name and password into the man in the middle, the malicious computer in the middle. It passes on my login information to the my bank computer. The bank computer sees that it's come from a new location, says, okay, I texted you a message, and says, enter in the ID number or unique code that I just sent you. The man in the middle passes that request on to me. I look on my phone, I see the number, I enter it, I pass it on to the hacker in the middle, and the hacker passes it on to the bank. The hacker is now into my bank account. Okay, if security is working properly and you are using security, man-in-the-middle attacks should not work. So there are a couple things that the person running the man-in-the-middle attack needs to have in order to get these things to work. The first thing is the man-in-the-middle requires the computer to be in the middle. So, you know, it's not like it's necessarily that easy getting between me and my bank. But there are ways it can be done, particularly like if it's the NSA or the FBI and they really want to attack me, well, you know, they can get some sort of a court order and actually stick something on the line between, say, me and the rest of the internet. So yeah, that's doable. But in general, something needs to happen that is going to allow the attacker to insert their computer between me and the computer that they want to simulate. They also need a way to overcome the identity protections and encryptions used by the website and by my web browser, assuming I'm actually using them. If I'm not, if I'm communicating with something using HTTP, which is the non-secure version of the web protocol, instead of HTTPS, which is a secure version, then all bets are off. Then it's just super easy. Then they just have to get between me and the website. Okay, how can they get around these problems? Well, you know, you may have heard people say, don't connect to random Wi-Fi points, or be cautious at web cafes and other situations where, you know, you sit down at Starbucks. Oh, here's a Wi-Fi router that looks like it's Starbucks. Sure, let me just go ahead and connect in there, because this is one place where you can insert a man-in-the-middle attack. So, you know, I think I'm communicating with Starbucks Wi-Fi, but in fact, I am communicating with hackers' Wi-Fi. The hacker is now between me and the rest of the internet, and they can run their man-in-the-middle scheme. How do you get around the certification encryption issue? One thing is you can assume the user will just accept the certificates. So if you log into the Stanford Unix machines, they will send you this big, long identification string saying, hey, here's my security identification. You can double check and make sure that this really is the Stanford computer it says it is. And the thing about the Stanford Unix computers is there are dozens of them. So there are dozens and dozens of these identification strings. And so basically every time you log into one of these computers, you might actually be logging into a different one. So, you know, the first time I might be logging into rice.stanford.edu, it might actually be rice 12. Next time it might be rice 5. Next time it might be rice 3. Then it might be rice 0. And so these all have different, very long, unique identification strings. And so if I start getting lazy, I don't bother looking up those identification strings and saying, oh yeah, that really is rice 12. I just accept it. This would allow somebody who's a man in the middle to pretend to be one of these computers and me not realize that it's actually a hacker's computer. Another possibility is to get a real fake certificate. And so just as an example, the Dutch Certification Authority DigiNotar was hacked and its private keys were compromised. And so whoever hacked them and got a hold of their private keys was able to generate new certificates claiming to be from DigiNotar, which was considered a reasonable certification authority at the time. The web browsers have since been fixed to not allow DigiNotar certificates to be used, and the company's gone belly up. We also talked about, I think I talked about earlier that when we talked about certification authorities, that somebody got one of the certification authorities to issue them a certificate claiming to be Microsoft when in fact they weren't Microsoft. It's also possible to get the user to install a new certification authority. So you visit the website and you get a message saying, hey, this website is using a certificate. I don't recognize the certification authority. Do you want to add Hackers Are Us as a trusted certification authority, and hope that the user is dumb enough to say yes? This is why, again, be extremely cautious adding new certification authorities to your web browser. In general, there isn't a great reason at this point for somebody to use a non-standard certification authority. Certificates have gotten cheap enough from reasonable certification authorities that this should not be an issue anymore. But the user visits the website. They think it's their bank. It's not their bank because they've been redirected by the man in the middle. They get a message saying, hey, your bank says it's got the certificate, but you need to approve this particular certification authority. You could easily see a naive user being like, okay, I don't know what the heck that is. I guess this is fine. I'm going to go ahead and click on the yes. And so they think they're now communicating with their bank. We've also had, this was really scary, but we also had a weakness in one of the Wi-Fi protocols, WPA2, that actually allowed a particular type of attack to grab the encryption key. This was discovered, we hope, first by a white hat hacker. And so these are the good guys. And so they basically said, hey, if I do this and that, I can actually get around the security on WPA2. And so they notified everybody WPA2 is not secure. We don't know of anybody who discovered this before everybody was notified, but it's certainly possible somebody else discovered this ahead of time and was using this in order to perform man-in-the-middle attacks. Okay, another issue that will come up, particularly if you're developing a website or you're writing software, is if you are using somebody else's software on your website, or you're using open source code as part of a project you're working on, you inherit the vulnerabilities of that software. So just as an example, I know a bunch of people who are working on this game project, and I visited their website, and I repeatedly was taken to a third website, which was clearly not associated with the original website. You guys have probably all seen this before, where you go visit a website and you instantly get taken to random download this game, or some other thing that clearly has nothing to do with the original website. What's going on there? Well, so I notified them, and they told me that they didn't realize this was happening because they never visited their website using a iOS web browser. They always visited it just on their PCs. But they did some research, and it turned out that they were using a plugin on their website, a WordPress plugin, and that WordPress plugin had been compromised. There was a new version of that plugin that avoided the problem, but yeah, basically because they used this WordPress plugin that had been written by somebody else, and that WordPress plugin had been hacked, their website was basically now hacked. So while the people who wrote that plugin had not intended to cause problems, they had intended it to be just a regular nice plugin that people could put in their WordPress websites. In some cases, the owner of that plugin or other open source project that you're depending upon may actually end up maliciously changing their code. So there's a couple circumstances where this could occur. One is if you're using open source code. Open source code means that anybody can go ahead and go in and modify the code. So the best prevention for this is to make sure that you are working with open source code that is widely used. The more widely it is used, the more likely there are lots of people looking at this code and making sure that if anybody inserts something into the code, it's going to be noticed and will be shut down. If you're using some open source project that's only being used by, like a dozen people, are those dozen people security experts? Are they paying attention to what's going on with that code? And so it's relatively easy to insert malicious code into those sorts of projects. So be super careful using open source code that is not widely used and widely studied. In addition, there have been incidences where somebody creates some sort of a free project, it starts gaining traction, and they decide, hey, maybe I'm tired of supporting this thing because honestly, it's a pain constantly supporting code that's changing. And so that they want out, and somebody else offers them a whole bunch of money and says, hey, we want to take over your code. Here's a wad of cash. And they're like, great, I want out. Here, you now control the code. I'll let my users know you're controlling the code now. And then what happens is that company that now controls the code, maybe they insert something into the code because it's no longer a free project. Maybe they add in some spying software, tracking software, or maybe something more malicious. So this is potentially a problem. So yeah, there's a lot of free software out there that's great. And I don't want to get people too paranoid, but do pay attention if the free software that you are using changes hands or is sold to another company. You need to know who now owns the software and if you trust them. Okay, here's another attack technique I ran into. This one's a little bit scary. This is vulnerabilities in the original IP protocol. And so you may recall that the IP packets bounce around the internet and they can get rerouted in different directions depending on what the internet traffic looks like. And so what happens in this type of attack is that the attacker starts sending information out about how the internet traffic is doing and forces internet packets through their particular computer. So as an example, in 2010, 15% of all internet traffic went through China for 18 minutes due to a, quote, misconfiguration of China Telecom's servers. So traffic routed through China included internet traffic from the US Senate, the Army, the Navy, the Air Force, the Office of the Secretary of Defense, and NASA. So basically what happened here was, China claims this was accidental, but what happened was China's telecom company basically told the rest of the internet, hey, you should route your traffic through us. We are the fastest way to get to your destination. So, if you're sending information from the Pentagon to the White House, it'll be faster if you route it through China. And the internet blithely went along with that and sent all the IP packets through China. In a different incident, in 2013, internet traffic from Mexico to the US was routed through Belarus for similar reasons. And, there's really no reason why traffic will go through Belarus if it was starting in Mexico and intended for the US. So what could this be used for? Well, for one thing, if there's anything unencrypted, any unencrypted packets going through, those can just be read. And this also, we talked a minute ago about how in the man-in-the-middle attack, you need to get between the person and the computer they're communicating with. Well, using a technique like this, you are now in the middle between that person and the computer they're communicating with. All right, so this gives you an idea of the variety of different ways computers can get attacked. Of course, there are many other ways computers can get attacked, but I hope this gives you a sense of the broad range of things that can happen to attack computers. Again, let me emphasize the social engineering one and the phishing attacks and the spear phishing, because that is the one that you are best able to personally protect against. If you're completely freaked out now, well, I'm a little freaked out myself. But in the next lecture, we will talk about ways you can protect yourself and defenses against various types of attacks. I look forward to talking to you then.